slowness. Yep. Okay. So, lab overview. The experiment is actually to measure the distance dependent of the magnetic field because of the small magnet and compare it with the actual, like, well, um, biosimilar. I don't know how to say that. Using a, yeah, magnometer app on your phone to determine. And these are the results that you'll see that we got in here. So the procedure, find the magnetic north by rotating your phone, um, and find the magnetometer shift by finding the y and minimum x values at the parallel and perpendicular points. And yeah. So these are my observations and measurements right here. So you can take a look at that real quick. So data analysis, as you can see, I just what's it called? Magnitude of the magnetic field due to the magnet is K times R to the N, and yeah, I experimentally derived this equation using the graph right here, using the ln K and ln R. Yeah, and using these, we found that the magnetic moment is 3.025. So model versus experiment. So we find the distance perpendicular where the net field is 100 microteslas, and we move the center of the phone up the um, distance of the perpendicular. And these are the data that I collected. They're only different results because the model only accounts for the electric field due to the magnet. But while the experimental is not in a like it's not in a what's it called? It's being affected by other things as well. And this are the glow script. It might be a little cut off because it couldn't fit it in these. But yeah, this is the code, and this is also the model that came out when I ran the code. And the conclusion is that when the magnetometer is far away from the magnet, it faces a near zero magnetic field when facing north on the x direction. As it moves closer, the field increases, and the distance dependence is r to the -3, and the moment is 3.025. So what if you hadn't oriented your experiment to compensate for magnetic north, instead laid your meter stick at some point intermediate angle with respect to the Earth's magnetic field? How would your results change? Well, it would have been skewed in the direction of the magnetic north, making your K, your mu, and your N less accurate. What if you were to stick two identical magnets together into N? The direction of the field wouldn't change, but the magnitude would double or less than double. Let's see, and that should